Welcome to Ganita Samayaha, an interactive learning space. Children, as I proceed with my teaching, whenever I pose in questions, please answer them. This will help you in the learning process. Also, please don't forget to have the writing materials with you whenever you watch these videos. And after you watch the videos, please subscribe, like and share them. Today we continue with triangles part 3. The link to triangles part 1 and 2 is given in the description box below in case you have missed them out. So let's get started. Children, in the last video I had given in an assignment. So let us go and discuss about this first. So it says that you are given a figure in which DE is parallel to BC and you are asked to find EC. So this is the figure that is given. That is, we have got a triangle ABC in which DE is parallel to BC. We have to find AC. The one concept that we have learned so far is that when we have two equiangular triangles, then their corresponding sides are proportional. So with that in mind, we need to identify two triangles and then prove that they are equiangular. So can we identify two triangles from this figure, children? Yes. Which are they? Triangle ADE and triangle ABC. Fine. Now we need to prove that these two triangles are equiangular in the sense that their corresponding angles are equal. It's very easy because we have got one clue, DE parallel to BC. So we get the corresponding angles equal. Isn't it, children? So if we consider angle AED, we know that it is equal to angle ACB and angle ADE is equal to angle ABC. So once we have identified that, let us write that down. Okay. So the solution goes like this. From triangle ADE and triangle ABC, we have DE parallel to BC. So, what else do we have because of this? Yes, angle AED is equal to angle ACB. We just now discussed. AED equal to angle ACB. Reason, corresponding angles. We need to write the reason whenever we make any statements like this, children. Is it clear? Next. Yes, angle ADE is equal to angle ABC. Again, they are corresponding angles. After this, we are left out with one angle, angle DAE and BAC. It is the common angle as well as the remaining angle in both these triangles. So, we write that as well. Okay, so since we have got the corresponding angles equal, we can say that these two triangles are equiangular triangles. So we say triangle ADE and triangle ABC are equiangular triangles. So that is done. We have identified two triangles. We have identified that they are equiangular triangles. Now, if they are equiangular triangles, we know that their corresponding sides are proportional. So we need to identify the corresponding sides. How do we identify that? We have already learnt it. We look for these two equal angles and look for the side opposite to these two equal angles. So with respect to angle AED, the side opposite is AD, and with respect to angle ACB, the side opposite is AB. So what is the ratio we have? AD by AB. Okay, then the next ratio, we should look for these two angles. The second one, ADE equal to angle ABC. So the side opposite to AD is AE and the side opposite to ABC is angle ABC is AC. So let us write the proportionality. We have AD by AB equal to AE by AC. Is it clear, children? Now we know all the three parameters. It is easy for us to find AC. Once we know AC, then we can find out EC, which is very easy. So let us substitute. The reason is corresponding sides of equiangular triangles are proportional. So after substituting and simplifying, we get AC as 3 centimeter. Since AC is 3 centimeter, AE is already given to be 1 centimeter. We have EC equal to 2 centimeter. Is it clear, children? So we have tried to work out a lot of problems using this particular concept that whenever we have got two equiangular triangles, the corresponding sides are proportional. Okay, children, let us go on to further understand and see how this one particular statement gets condensed further and makes our work easier. The same problem we will be working out later with a condensed, just a few more, just very few steps, children. Okay, so let us explore further and understand a few more concepts till then. Let us take a quick recap on what we have learned. Yes, I have told it a number of times, repeated. I'm sure all of you have got it also. Let us just say it once. Two triangles are similar if and only if the corresponding angles of the two triangles are equal and the corresponding sides of the two triangles are proportional. Then later on, we have come across another statement also which we just used it. What is that statement? In two equiangular triangles, the ratio of any two corresponding sides is always the same. Now, are we wondering if the two are different or they are same? Do we have to know two different concepts? No, they are the same concept. Again, let us see how it is. Okay. When we understand, this is the first condition, the corresponding angles of two triangles are equal. When we say the corresponding sides of two triangles are equal, then what is a special name given to that type of triangles, children? Just now we have studied about it. Yes, they are called as equiangular triangles. So this complete sentence has got condensed into just one word, equiangular triangles. So that is the condition. If you have two equiangular triangles, is it clear, children? That if you have means what? You must prove that they are equiangular triangles. They mean one and the same. It is just a condensed form. So if you have two equiangular triangles, the ratio of two corresponding sides is always the same. That means what? The corresponding sides of the two triangles are proportional. When do we say two sides are proportional? When the ratio of two sides is equal. Proportionality means what, children? When the ratios of two parameters, okay? If when two ratios are equal, we say they are proportional. It is the same thing. So they are not different. We have understood one and only one concept so far. That is, in two equiangular triangles, the ratio of any two corresponding sides is always the same. This is the only concept we have understood so far, and we have worked out problems related to this only. Okay, so we go further to explore how this can be condensed more. Is it clear, children? Okay. Now, let us see how we understood these two concepts, children. Two triangles are similar if corresponding angles of two triangles are equal and corresponding sides are proportional. We have understood. But how did we come to this conclusion? Yes, by observing certain figures and by doing an activity. Let us take just a small recap about what we did to understand this concept. I'm sure you all have not forgotten about it, but I just want to remind you. What did we do? We observed a few figures which did not have the same shape, and we concluded that for these figures to have the same shape, their angles must be the same. So that is how we got the first condition, isn't it, children? And then we went on to discuss that the sides must be proportional for both the polygons to be similar. This is how we arrived at the conclusion. So in both these cases, we have observed some of the figures. Is it clear, children? Through that, we came to a conclusion and then we enhanced it. That is, we substantiated it by doing an activity. Do you remember that activity? Yes, We took a ruled sheet of paper, drew a triangle, and then we found out the ratio of the corresponding sides, and we found that it is equal. So through observation and through activity, we established the relation that in two equiangular triangles, the corresponding sides are proportional. But in mathematics, we require logical proof. Isn't it, children? So let us try to prove this statement logically now. Are you all ready? Yes. Let us get started. So what does the statement say? If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. This statement is written in a different manner, that's all. But from where did we get this statement? Just recollect the activity that we did. What did we do in that activity? We drew a triangle and we drew a line parallel to one side of a triangle. The same thing. That was the we know that any theorem has got two parts, the hypothesis and the conclusion. Whatever we did and whatever is given to us is the hypothesis. Isn't it, children? From this activity only we have got the statement. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, okay, then the other two sides are divided in the same ratio. This is what we need to prove, and we have to prove that with logical statements. So let us get started. You know the format to write the proof for any theorem, isn't it, children? The first one that we should do is write what is given to us. What is given to us? We are given a triangle. Here we have drawn this figure and we have named it as ABC. So we write we are given a triangle ABC. How? We have got the statement. If a line is drawn parallel to one side, that means in which we have got this line DE drawn to BC. So we write in which DE is drawn parallel to BC. So this entire given forms this first part of our theorem. Okay, and we can see that in the figure as well. So this is all that is given to us. You are given a triangle ABC and which line DE is parallel to the side BC. This is all that is given to us. So what should we prove? Yes, we have to prove the other two sides are divided in the same ratio. BC is one side that we know. So which are the other two sides left out? AB and AC. And DE is dividing AB and AC at two distinct points D and E. So we have to say that D and E divides them in the same ratio. That means AD by BD is equal to AE by EC. That is what we need to prove. Okay, children. This is all that we are given. Is it possible for us in any manner to get this ratio AD by BD or AE by EC? Just like that, we cannot get it. So we need to do some construction. Okay, children. The construction that we are going to do is we are going to find out somehow the area of this triangle ADE. Okay, children, when I try to find the area of this triangle ADE, what is the area of a triangle formula? You have learnt it. It is half into base into height. So, when I consider triangle ADE, I will consider AD as a base. Then I require a height. Isn't it, children? Height must be a perpendicular drawn from the opposite vertex to this base AD. So I will do that as a construction. I will draw some line from E perpendicular to AD. Similarly, I can also have AE as a base. Since I want AE as well here, if I want AE as a base, then what should I do? I should draw a perpendicular from D to AE. So that will be the construction. Is it clear, children? So why are we drawing this? We want to get this part AD somehow. For that we are going to draw this perpendicular from the vertex. Okay, and then we are going to try to find the area of this ADE. And then here we have got DB. this part dB. That means we need to have a triangle with dB as a base as well. So to do that, what should we do? We will join BE, that's all. When we join BE, we get another triangle DBE. Similarly, we want EC. When we want EC, what should we do? We will join CD. So we get another triangle DEC. Is it clear, children? So that we get these triangles there, we do this construction. So what is the construction that we will do? We will join, we will construct a EN perpendicular to AD and DM perpendicular to AE. And we will also join BE and DC. So this is the construction. We will write that now. Okay, children, as soon as you see this theorem, please don't try to take it from memory. You should understand the concept that here we are going to try to find the area. To find the area, we need height. So that is why we have constructed height for the small triangle ADE, and we need one more triangle so that we get these bases BD and EC. So we are joining BE and DC. Okay, so this is the concept that we have to understand and not always take it from memory. Okay, children. So we write that construction is draw DM perpendicular to AE, EN perpendicular to AD, join DC and BE. So much we have done. Now we have to see how we get this ratio. Okay, so I told you we are primarily interested in finding the area. So we want AD by BD. So we will compare the area of this triangle ADE and this triangle BDE. Is it clear, children? So when we compare these two triangles, what happens is, just observe this triangle ADE. We know AD is a base and NE is a height. Okay, children, when you consider this triangle DBE, DB is a base, and since angle BDE happens to be an obtuse angle triangle, the height of this triangle will lie outside the triangle. And this EN happens to be the height of this triangle BDE as well. Is it clear, children? For this triangle ADE and for the triangle BDE, NE happens to be the common height. Similarly, with triangle ADE and triangle DEC, DM happens to be the common height. When AE is the base, DM is the height for this triangle ADE. And for this triangle DEC, if we consider EC as the base, then DM will be the height. So DM is a common height to triangle ADE and DEC. Is it clear, children? So we will now compare area of triangle ADE and triangle BDE. Comparing means what? We find the ratio of these two triangles. Okay. So the ratio of area of triangle ADE by triangle BDE. We will have to find out. You can see that NE is the common height for both these two triangles ADE and BDE. Okay, children. So area of triangle ADE by triangle BDE. What is area of triangle ADE? We are considering AD as a base. So it is half into AD into NE. And what is area of triangle BDE? Half into BD into NE. So we write that. Okay, children. Now what happens? This half and half gets cancelled. NE and NE also gets cancelled. We are left out with this ratio AD by BD. Hence, we have area of triangle ADE over area of triangle BDE is equal to AD by BD. Let us call this as statement 1. Is this clear, children? We have just compared the area of these two triangles on the left hand side with triangle AD and triangle BDE. Is it clear, children? AD as base and BD as base. NE is the common height. Now we will compare triangle ADE and triangle DEC. Now we will consider AE as a base for the triangle ADE and EC as a base for this triangle CDE. That's all. So area of triangle ADE by ECD will now become half into AE into DM. This is the base. AE is the base and DM is the height. And for this triangle EC is a base and DM is a height. So we have half into EC into DM. I am sure you have got all this concept with your children. Okay, very easy. Just we are comparing the areas of these two triangles and we know what the area is. Formula from the lower classes we have done it. We have just written it, that's all. Again here half and half gets cancelled, DM and DM gets cancelled. We are left out with area of ADE over area of ECD is equal to AE by EC. Let us call this as statement 2. So we have got two statements here, children. Area of triangle ADE over area of triangle BD equal to AD by BD, and we have got area of triangle ADE by area of triangle ECD equal to AE by EC. What do we need to prove? These two right hand sides are equal. When will the right hand side become equal? When the left hand sides are equal. Okay, so let us look into the left hand side. In the numerator we have got area of triangle ADE. Here also we have got area of triangle ADE. So both are same, no problem. But the denominator here we have got area of triangle BDE and here we have triangle ECD, BDE and ECD. Now if we can somehow prove that these two areas of triangle BDE and triangle ECD are one and the same, then our problem is solved. Okay, children. So let us observe these two triangles DEB, DEC. So which is the base for both the triangle DE. That means both the triangles are standing on the same base DE. DEB, DEC. Isn't it, children? And then they are between the same parallels DE and BC. See, DEB is on the parallel line BC. DEC is also standing on the same parallel BC. So do you recollect what you have studied about areas of triangles last year? Triangles standing on the same base and between the same parallels have the same area. Why? Simply because we know area of a triangle is base into height. Here base is DE for both. What is the height? Height, when you consider DE as a base, the perpendicular from B you have to draw. Since EDB is an obtuse angle, it will be a perpendicular which lies above, which lies beyond this triangle, is it outside this triangle? That means it is the perpendicular distance between these two parallel lines. Same thing with this triangle DEC. Base is DE and height is the perpendicular distance between these two triangles. Hence the areas are equal. Okay, so don't get confused. The triangle DEB and triangle DEC are two triangles standing on the same base and between the same parallel. So these two areas will be one and the same. That means what? Yes, we have area of triangle BDE equal to area of triangle CDE. That means when LHS is same, the RHS also becomes the same. So we have AD by BD equal to AE by EC. Is it clear, children? That means why is AD by BD equal to AE by EC? Things equal to the same thing. These two are different things, but they are equal to the same thing, isn't it? AD by BD is equal to something. AE by EC is also equal to the same thing. So things equal to the same thing are equal to one another. This is the axiom. So from this, we have proved an important statement. What was that, children? Suppose you have a triangle and if you have drawn a line parallel to the other side, it is dividing the other two sides proportionally. So if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So this we have already proved logically. Is it clear, children? And this statement has got a special name again, and it is called as the basic proportionality theorem, written as BPT, or it is also called as Thales theorem. Okay, children. So this is the theorem that we have established so far. So what does this statement say? If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Okay. So this is a very important theorem, for the proof of which you must be able to write on your own as well. Okay. So now let us see how this theorem is helping us in solving the problem in with lesser time and with lesser steps. Okay, children, it is the same thing. It is given in a different form, but now this will help us to establish some solutions in a very easy manner. Let us look into it. So before that, we will just discuss how we have to identify the corresponding sides with triangles that have got different orientation, children. Suppose you have got a triangle ABC like this and DE parallel to the base BC. Normally, we write the base here, horizontal line, isn't it, children? In this case, it is very easy. We just take any one of the vertex, okay? And then from there to this point, AD by BD. You can write either BD or DB. It doesn't matter. It's a line segment. It's just the measure. AD by BD is equal to AE by EC. Okay. Start from this vertex and go top, bottom. Again, top, bottom. That is the rule. You should not by any mistake write it as AD by BD equal to CE by AE. That is not allowed. Isn't it, children? So it has to be top by bottom. AD by BD equal to AE by EC. Of course, you can write it as BD by AD equal to CE by AE as well. Okay. Top by bottom, or bottom by top and bottom by top. So you must be careful how you write this proportional. You might have a triangle with a different orientation. See, now we have got LM parallel to PR. The orientation is different, not like this, isn't it? So in that case also, what do? We choose Q as the vertex, the side opposite to this parallel line we choose. Safe. You can choose anything else, but that is safe. Then we go QL by LP equal to QM by MR. Is it clear, children? So, QL by LP is equal to QM by MR. That is how we have to write the proportionality. So, now your problem will lie in identify the triangle and the line parallel to one of the sides. After you do that, then you can write the proportionality. That is what we are going to understand and do now. Is it clear, children? So this is the key point that you should start doing now. Or you might have a orientation like this as well. So in this way, in this case, what will be the proportionality that we will write? Yx is the line that is parallel to PQ. So we choose the vertex opposite to these two parallel lines, which is Z. Then we can write it as ZP by PY is equal to ZQ by QX. Okay, children. So we will bear these things in mind and let us do a few problems. This is the same problem that was given to you as assignment. In that case, what did we do then? We tried to prove that this triangle ADE and ABC are equiangular, and then we wrote the proportionality. But now our BPT has helped us. Okay, let us see how. It is the same problem, children. We have a triangle ABC in which DE is parallel to BC and we have to find EC. Okay. So we know DE is parallel to BC. Immediately what can you write now? Yes. You can write immediately AD by BD equal to AE by EC. Earlier when we did the same problem, what did we do? We tried to prove that these two triangles ADE and ABC are equiangular, and then we looked for the side opposite to the equal angles and then wrote the proportionality. Isn't it, children? And then we got AC. After getting AC, we found out EC. But now it is become very simple. So much of a steps has got condensed now. Directly we can write because of our basic proportionality theorem. Isn't it, children? Okay. So we have AD by BD equal to AE by EC. We know all parameters. We substitute and we get EC equal to 2 centimeter. Very simple, isn't it? So henceforth you can start doing the problems using BPT. Then why did we learn the other one? Yes, we learned it so that we know to identify the corresponding angles and corresponding sides which we will be using it later. Okay, children, and problems were given so that you get equipped in finding out the equiangles and the corresponding sides. That is why that exercise was given. Okay, temporarily we will not think about it, but you should not forget that concept. Okay, henceforth, if you have a triangle and if you are able to identify any line parallel to one of the sides, you will directly use this BPT. Actually, here you must write BPT, children. I forgot to write, but you don't forget to write. Okay, you must write here reason as BPT. You must write here. This is the reason. Whenever you make statement, please don't forget to write the reason. So let us look into one more problem, children. Yeah. Here you are given a figure in which DE is parallel to BC. You are asked to find AD. Very easy, isn't it? Our BPT has helped us. So from triangle ABC, DE is parallel to BC. So we have a, yes, I'm sure all of you know how to do it now. AD by BD equal to AE by EC. Reason BPT. You must write here again. BPT must be written here. Okay, you must write that. Reason is BPT. Okay, so on simplification, we get AD is equal to 2.4 centimeter. Dear children, let us work out one more problem now. Yeah, we have got a triangle ABC and then all these parameters have been given, but they are given in the form of a variable including x. This is some x, this is x minus 2, x plus 2, x minus 1. That's how we are given. You are asked to find the length of the side AB and AC. Okay, so we have identified DE is parallel to BC. Once we identify that, what should we do? Write the proportionality. That's all. Very easy. BPT is making our work very simple. Identify which are the lines that are parallel and immediately write the proportionality. So what is the proportionality that you can write? We have got DE parallel to BC. So from triangle ABC, we have AD by BD equal to AE by EC. You know all the parameters in terms of x. Substitute. Simplify. Yes, you have to write BPT there. X over x minus 2. See, x over x minus 2 is equal to x plus 2 over x minus 1. Just these measurements are substituted. After which, it is simple algebra. Isn't it? Cross multiply and simplify. I hope you all know this, children. These two are cross multiplied. X into x minus 1 is equal to x minus 2 into x plus 2. So you simplify that. We have x squared minus x equal to x squared minus 4. I hope you remember this formula. A plus b into a minus b is a squared minus b squared. So x minus 2 into x plus 2 is x squared minus 4. Again x squared and x squared will get cancelled. We are left out with minus x is equal to minus 4, which implies that plus x is equal to plus 4. So knowing the value of x, substitute and find out the length of AB and AC. What will be the length of AB? It will be AD plus BD. So it will be x plus x minus 2. Okay, so AB is equal to x plus x minus 2, which is nothing but 2x minus 2. Substitute x as 4, you get 2 into 4 minus 2. So AB is equal to 6 units. If units are mentioned specifically, you'll write the units. Otherwise, you'll write it as simply UNITS, units. Okay, children. So we have AB as 6 units. Similarly, substitute for x to AC. What is the length of AC? X plus 2 plus x minus 1, which gives us 2x plus 1. Substitute x as equal to 4. You have 2 into 4 plus 1, which is 9. So we have AC equal to 9 units. So this is how we try to do the problems by using BPT. Yeah. Let us look into this one, very interesting one. Okay, so you are given a figure, that is you are given a triangle ABC in which DF is parallel to AE and DE is parallel to AC, and we have to prove that BF by FE is equal to BE by AC. Here what is interesting is we have got two conditions here, children. Whenever you have got two conditions, that means you should look for two statements and compare them. So in the question itself you will have the answer. The clue is here. That is what you should look for. First let us consider DE parallel to AC. Which is that DE here. DE here you can see, isn't it highlighted there? It is parallel to AC. You can see that we have highlighted it here. Okay, when you consider DE parallel to AC, so which is the triangle that you should observe now? Only this triangle ABC. Just to forget temporarily about the other lines. I have just removed it for you so that you get a good picturization. But you cannot remove it. You should know how to picturize this, children. Okay, so we have got DE parallel to AC. Now we can use our BPT and write the proportionality very easily, isn't it? So how do we write the proof? We write it as DE is parallel to AC, which is the triangle. From triangle ABC, we have, what do we have? BD by AD equal to BE by EC. I am sure by now all of you are able to write this proportionality. So we have DE parallel to AC. I told you choose that vertex that is opposite to these two parallel lines. We have chosen B. So BD by AD. Again from B you have to start. BE by EC. We have written this. Okay. So and the reason is BPT and we call this as statement 1. Is it clear? Now, this is our actual figure that is given to us. What is the other condition that is given? DF is parallel to AE. Isn't it, children? DF is parallel to AE. We have highlighted those two. Now, which is a triangle that you should observe now with DF parallel to AE? Okay, AE must be the base and DF is parallel to this. So which is the triangle? You should consider only this triangle. Okay children, I have given it so that it will be easy for you to visualize it. Okay, now again we have got DF parallel to AE. So which is the vertex opposite to this parallel? B. So with this B as the vertex, we will write the proportionality. So what is the proportionality? How do we write up this? We have to write it as DF parallel to AE, and which is the triangle that we are going to consider? ABE. From triangle ABE, we have BD by AD equal to BF by FE. Again this is BPT and this we call is a statement 2. Isn't it children? So this is the figure that we have and we have written these two statements from this figure. Now let us observe this true statement. What do you find? LHS is same. BD by AD is equal to something. Again the same BD by AD is equal to something else. So things equal to another, the two things that are same, the things equal to each other are equal to another thing, isn't it? BD by AD is equal to BE by AC. BD by AD is also equal to BF by FE. So what do we have comparing these two? We can write that BF by FE is equal to BE by AC. This is what we want and we have proved it. The reason for this is things equal to the same thing are equal to one another. Okay, children. So such problems also you must be able to work it out on your own. So the important clue is you should consider which are the one triangle in which the lines are parallel to each other. So first we had this DE parallel to AC. So you take that triangle along with ACB. Okay, AC and B, this was a parallel, isn't it? So we took this triangle ACB and then you write the proportionality. And then what did we do? We took DF parallel to AE. So we take the triangle along with this base AE. This is DF is inside this triangle, isn't it? So AEB, we look for that and then look at this line that is parallel, write the proportionality. So with this entire figure you must be able to visualize. Very easy. Identify the triangle, identify which is the line parallel to one of the sides, identify the vertex opposite to this parallel and then write the proportionality. If you are given two conditions, that means you will get two statements like this. Just compare them. You must have one side, either the left hand side or the right hand side equal, same thing, it will be the same, and then just you have to equate the RHS. That's all, children. So all these problems are very easy. Understand the concept, you will be able to do them. I hope it is clear to you, children. So I have got an assignment for you as usual. There are two problems. Please look into them and work out on your own. Okay, without any other help. You can see this video again and again so that you get a clarity of the concept. Once you have got that, please work it out. We will discuss the same thing in the next video. Okay, children, let us take a quick recap on what we learned in today's video. What did we learn? We learned that the statement of basic proportionality theorem, which is called as the BPT or the Thales Theorem. And then we have understood the proof of BPT. All of you, please practice writing this proof, children. Okay, you must be able to write it on your own. And then we have solved problems using BPT. So for this, we try to identify which is the line parallel to one of the sides and then we know how to write the proportionality. Once you are done that, you will be able to solve these problems. I hope you have enjoyed watching this video, children. If you have any doubts, please put them in the comment box. I will get back to you as soon as possible. Please don't forget to share, like and subscribe to this video, children. So thank you for watching the video. Thank you.